everybody, this is Harbin. Video notes 4.2 on the way. This is from the last video notes, but we're still going to do it. We're going to be able to, it's from the last notes, and we're still going to do it. Here's the new one. Okay, let's get busy. Okay, read chapter 7. Hey, try number 18 and 19 on page 199 for bonus. Yeah, I said it, bonus. Okay, so what happens when lithium meets fluorine? Well, lithium's a metal, and fluorine's a non-metal. They have totally different electronegativities, like a huge difference. So fluorine actually takes an electron away. So then you get lithium ion. It's a cation, well, and a fluoride ion, -1 charge. And they make the compound lithium fluoride, which is LiF. All right, ionic compounds, positively charged things attracted to negatively charged things. Okay, total ions all day. So, how do we know it's an ionic compound? Well, we look for metal or ammonium, and then we look for non-metal or polyatomic ion. So, this is ionic because it's got a metal and a non-metal. This is ionic because it's got a metal and a polyatomic ion. This is a non-metal and a non-metal, so this is covalent. I'll try to throw one at you, see if you got it. This is a polyatomic ion and a polyatomic ion together forever. Yay, charges. This is a non-metal and a non-metal. Oh, gotcha again, covalent. And this is a non-metal and non-metal, and it has a charge, so this is just a polyatomic ion all by itself. So it's not a compound. Okay, not a compound. So, here's the deal. Compounds have no charge, and it's got more than one atom. And if it's an ionic compound, it's got metals and nonmetals, or it's got polyatomic ions built in, but not a compound if it has charge. All right, ionic compounds have a metal ion or ammonium, and a non-metal ion or polyatomic anion. So positives and negatives must balance. Sodium sulfide. So I'm looking at it going, all right, sodium, I know it's on the metal side, Na. Look at what column it's in, it's a +1. Sulfide is in the non-metal side, it's in the -2 column. You got a plus and a -2. That doesn't equal 0. This would equal 0. So sodium sulfide is an ionic compound, it's Na2S. And that is one amazing element. So, examples of formulae for ionic compounds. Calcium, find it on the periodic table. Metal, bromide, comes from bromine. Totally ionic, metal and a non-metal. Here is the zigzag border. So we write the symbol and the charge, symbol and the charge. 2 and a 1 do not cancel. So I need a calcium and I need 2 bromides because it's got to equal 0. Okay, so this is calcium bromide. Aluminum +3. Why? Because aluminum's always +3. Zinc's always +2. Silver's always +1. These are always +1. These are always +2. Oxide is right here. We got a -2, -1, -3. Hebrew. Oxide comes from this column, -2. Uh-oh, that doesn't equal 0, so I need more negative. But that doesn't equal 0, I need more positive. But that doesn't equal 0, I need more negative. So I need Al2O3. Magnesium oxide. Well, here's magnesium in the +2 column. Here's oxide in the -2 column. MgO, gotta go. Right, so, writing formulas and names for ionic compounds with polyatomic ions in it. So did you memorize the polyatomic ions so that when you saw them, you'd recognize them? Hey, there's one acetate, and it's with sodium. Sodium is an Na with a +1. Acetate is C2H3O2-. Unless you memorize the CHECU, bless you, form of it. So it's a +1 and a -1. It's NaC2H3O2. Hey, no more charge because it equals 0. Magnesium's a +2. Where is it? Right there. Boom, 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 boom. All right. Sulfate, you memorize SO4 -2. So we got an Mg with a +2 and a sulfate. So it's MgSO4. Why don't I need any subscripts or parentheses? Because it's one of each. Aluminum's a +3, always +3, +2, +1, always. Sulfite, SO3, -2, 8 and 8, yeah, they're related. So this is a +3, -2, that still doesn't equal 0. Now it does. I have aluminum, 2 of them. Now, sulfite is the whole thing. So I put it in parentheses and say, give me 3 to make my compound. So, how do we write the formulas? We put how many of each ion make the compound 0. I need 3 sulfite ions. Ammonium, NH4+. Carbonate, CO3 -2. You got it memorized. But wait a second, that doesn't equal 0. I need another one of those. Okay, now I have 2 ammoniums, NH4, but I have to put parentheses because I need 2 of them. Carbonate, CO3, just one of them. Okay, why didn't I use parentheses there? Because I only need 1 in the compound. Even though it's polyatomic, I only need 1. Here I need 2 ammonium ions, 2 of those. Right, KCN, wait, what? Am I going to write a name for that? Yes. I need the name of the first thing, and the name of the second part, cyanide. Cyanide. Now, we're going to learn on the next couple slides, but do I need a Roman numeral here? No, because potassium's in the always +1 column. Hey, it's barium. I dotted my I before it was even there. And then this, polyatomic ion, hydroxide. Alright, let's keep practicing. So, here are some rules. I recommend pausing the video right now, writing down these rules. Okay? So, how do you know it's an ionic compound? Well, it either starts with a metal, has ammonium in it, and there's no charge. Okay. So then you write the charges and make sure you use enough of each ion to make it 0 overall. Then put parentheses in the formula only to keep the polyatomic ions together if there's more than one. And then remember that when you're done writing the chemical formula, there's no charges because they equal 0. Boom. So, Roman metals, you need to name them. So, or you have to recognize what they are when you see their name. So you have to know the Roman numerals, up to 8 at least, okay? Well, really up to 7, and we probably won't even use it. But this is the Roman numeral 1, 2, 3, 4, 5, 6, 7, 8. Please write those down and know them so when you see them, you know which one it is. For example, look at this. There is 3III. Okay, so what this means is that the iron in this compound has a charge of +3. I don't even have to look at a periodic table. You know why? Because it tells me right there. Chloride comes from chlorine. Chlorine is in the -1 column. Hey, this doesn't equal 0. Still doesn't equal 0. Now it equals 0. So now I write it down. FeCl3. Do I use parentheses? No, because there's no polyatomic ion. So I write the formula by canceling charge. Boom, did it. All right. Hey, it's more Roman practice. Why do these all have Roman numerals in them except one? Well, here's why. Copper is in that place on the periodic table that's not an always, so it's a transition metal. So Cu, all right, Cu what? Cu +2. Oxide O -2. How do I know? Periodic table. Okay, so then you put them together. CuO. Hey, what's this? It looks very similar, except that this time the copper is a +1 charge. How do I know? Boom, 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 boom. That's how you know. Oxide's -2 because oxide is in the -2 column for nonmetals. Now I'm going to need some more copper. I'm going to need Cu2. Let's Cu2. Oh. Titanium, Ti. What does this 4 mean? It means +4. Bromide, Br. I know it's a -1 from the periodic table. So, whoa. Look at all those bromide, titanium, bromide. Okay, yeah, I'm saying potassium nitrate. Wait a second, Mrs. Harbin. Why is there no Roman numeral? I'll tell you why. Because if you look on the periodic table, potassium's in group 1, and group 1 is always a +1 charge. That's why nitrate. I am so glad you memorized these because you don't even have to look anywhere. It's right there. And then you can NO3. Right. Lead 4. What? Pb. IV +4. IV +4. +4. Right. Carbonate. Oh, good. You memorized that one. CO3 -2. Wait a second. This has to equal 0. I'm going to need some more carbonate. Alright. So overall, I need 2 polyatomic carbonate ions to cancel out the charge on lead. Alright, moving on. How do we name them? Oh, this is different. We have the formulas. First of all, you know it's an ionic compound because it's a metal, right? And then a non-metal. So we're going to need to write the name of the first part, copper. Write the name of the second part, but change the N to IVE if it's from the periodic table. Now, this is not an always metal, so I have to put a Roman numeral. How do I know what to put? Here's a Cl and a Cl. Okay, come back. And then here's a Cu. Now, it doesn't tell me the charge on Cu. I got to figure it out, but we know it got together at 0, so this must be a +2. So I'm putting a double I right there. Okay, CO is cobalt. NO3 is nitrate, so cobalt nitrate. Wait a second, cobalt is not always the same charge, so I'm going to need a Roman numeral. How do I figure out what it is? Well, I know nitrate is NO3 -1, and there's 2 of them. I know there's 1 cobalt in the compound. So this had to be 0 when it got put together, so it must be a 2. Boom, boom, cobalt 2 nitrate. Hey, you, give me that gold chain back. That's a metal. NO3 is still nitrate, just like it was yesterday and the day before, and it is right there. Okay. Gold is a transition metal. It's not and always the same, so we need to figure out the charge. But nitrate is a -1, so there's 1 gold, 1 nitrate, it's -1, it must be a +1, so I have to put a 1 in parentheses. Always got to do it. Fe2O3, okay, transition metal called iron. O is any dioxide. Now, I have 2 irons in this compound. I have 3 oxygen in this compound. I don't know the charge on iron, but I gotta put its charge in parentheses. I do know oxide is -2. This gives me a total of -6. Iron must be +6 because it got put together to be 0. That means each of these irons must have a +3 charge, so I'm going to put 3 in parentheses. Aluminum nitrate. Okay, how do I know to write that really quick? Well, I don't have to write it really quick. I know it's aluminum nitrate because Al is a metal, NO3. Oh, I said nitrate. Hold your horses, Harbin. I don't have any horses, but if I did, I would name this horse nitrite because it's a 2 here. Okay. Now, one more thing. Do I need a Roman numeral? Hold up there too. Aluminum is always a +3 charge, so I don't need a Roman numeral. Okay, this is lead. And this you memorize is carbonate. Do I need a Roman numeral? Hold up, let me see. Lead is not always the same charge, so I need a Roman numeral. I know I have 2 carbonates in this compound and 1 lead. Well, let's see. This is -4, so this must be +4. Right? Just watch what I'm doing. Try and figure it out. -4 here, +4 here. So I have to put an IV into lead. Get it? IV into, never mind. It's lead 4 carbonate because the lead has to have a +4 charge to go together with carbonate. And I have to put it in there because lead's not always the same charge. Okay. Just to review, you have to know, this is an objective, you have to know these things. So monatomic ions mean 1 atom but it has a charge. Here's a monatomic ion. What's its name? Well, it's iron. And because iron is not an always metal, we need to put the Roman numeral 3. That's an iron 3 ion. Oh, look, it's a monatomic ion. So this is calcium. Do I need a Roman numeral? No, but I have to put the word ion so I know it has a charge. Sulfide. Sulfide comes from sulfur. But when it says IDE, it must be coming from the periodic table, and it must be an ion. Okay, lead 4 means I have the symbol for lead. This IV means it's a +4 charge. These are all called monatomic ions because it's 1 atom with a charge. Some need Roman numerals. Some are non-metals with a negative charge. All of the metals are positive cations. Okay, polyatomic ions. How do I know this is polyatomic? Because it's got 2 different atoms in it. So I need to know its name. It's hydroxide. Yeah, memorized. Yeah, Ohio negative. C2H3O2 negative. It's an ion. Which one? It's the acetate ion. Acetate. Okay, ammonium. NH4 plus. This is why we memorize them. Phosphate. PO4 negative 3. All right, moving on. Please, please memorize your ions. The always metals always lose the same number of electrons, so they always have the same charge. Group 1 plus 1, group 2 plus 2, aluminum, zinc, and silver, 3, 2, 1. That's a little place on the periodic table right there, 3, 2, 1, 5, 5. The Roman metals are roaming around with their charges, so they have to have a Roman numeral in their name that tells the charge. The Roman metals are transition metals and a couple under the stairs. When you write a formula cancel charge, name the cation. Use Roman numerals if it's not an always metal, and then name the anion. All right, we're going to keep practicing. Hey, did I say you could have bonus? I sure did. You can have bonus. All right. The 3 things we learned in this video notes, we went over this. Hopefully you know the metals that can form more than 1 ion. Those are the transition metals. They can lose 2 electrons, 3 electrons, 4 electrons. And then make sure you can write the formulas of ions and ionic compounds, and then use Roman numerals when you need to, and parentheses when you need to. Peace out from Harbin.